So now let's talk about the function notation and versus actual equations. So as we explained earlier, so we just give three examples about the functions: y equals x plus 1, y equals x, and y equals square root of x minus 1. So they're all actual equation of the functions, but sometimes we can simply write as y equals fx, right? So and then maybe that's one function, and then y equals gx. This is a different function. So f and g here is just means function of x. But in mathematics we can really see the f really uh, means an expression in terms. Okay, so basically, f means an expression, and then let me make it clear. So f means an expression, and then the square root, the bracket means as in terms of. And finally, if you put x inside the bracket, it really means the whole thing means, oh, that's an expression in terms of x. And of course, the gx means an expression in terms of x as well, but it's a different expression since you can tell from the f and the g, the different letter. Okay, so and then the actual equation, of course, were mentioned, so they just should be explicitly show what kind of expression is, right? And then that's a function notation. Okay, but let's quickly talk about the understanding about a function. A function is really like a machine. Okay, so for example, this function is really, let me put it here. So this function is really this is a f, right? F is a function. So if you take something in and I put x in, and then after the calculation of the f, and then they're gonna produce a y. So it's just like a machine, right? You fill in something, you feed in something with x, and then you produce the product, which means the y. And here is just a different function, so we can label the function as g, and then here you put something in, so x, and then it should produce a different y. Okay, so just like a machine. Okay, so that's your basic understanding about function, but don't get confused with the actual equation. So they're different. So a function only in general say, oh, there's an expression, but the actual equation tells you what kind of expression it is. Okay. So then let's focus on the difference between different kinds of functions. So there are two categories. One is called a linear function, like y equals 2x plus 1. So that's linear, right? Linear. So which you learned in grade 10. X equals y equals negative x plus 1 over 2. Another linear function. So any linear function, you can notice that the exponent of the x is equals 1. So it's just exponent of x, which is a variable, independent variable, equals is 1. Now, by the way, in any function, we call the x be independent variable, and the y is a dependent, and just like the machine. So the y is a product. It's depending on what kind of x you put it in. So that's why we call it independent for x, dependent for y. So that's a linear function, and then basically the reason it's called linear because if you graph them, it's a straight line. Its graph is a line. And then, of course, if we talk about non-linear linear function, there are a lot. So like y equals square root of x minus 1, the one we just mentioned. So it should be a curve. So if you graph, it's not linear, not a line. And then the thing we're going to focus on is this kind of thing, y equals x squared minus 1, for example. So they're not, so especially this one is called a quadratic function. Okay, so quadratic function, if you look at the right side, so it's a quadratic expression, right? So it's a quadratic expression, and then if this is the equation for this is the expression for the function. So we already mentioned the function is just y equals an expression. Now if the expression is a quadratic expression, so then the function is called a quadratic function, right? So and then its graph, their graph not linear. Okay, they're not a straight line. So I think I should have mentioned see okay. And finally, I just want to briefly talk about the equation versus graph. There's nothing much to talk about this, and the graph is just a visual representation of an equation. So anytime if you given a function, for example, y equals x squared minus 1, for example, now to graph this, the general idea is you can create a table, right? So you can create a table like this and say x equal y equals, right? So say when x equals 0 and y should equal -1, when x equal 1, then y should equal 0. When equals to -1, then y should equal 0 as well. Yeah, and then you can give more value when x equals 2, y should equals 2 squared, you should get a 3. Y equals, if y equals negative, x equals -2, you should also get a 3 as well. So then according to these points, you can basically plot all these points. See when x equals 0, you got -1, so you got 1 point here, and then x equals 1, and you got a 0, so you got a point here, and when x equals 2, y equals 3, so -2, it's also 3. So then if you connect them with a smooth, remember you always connect them with a smooth curve. Okay, see, that's actually called a parabola. It's normally any quadratic equation more or less look like this. And of course, sometimes the open is going down, sometimes it's up. But in general, the shape looks like this. Okay, so I think we are ready to start the new lesson.